3, I will execute this command. I will say like this, and then I will execute this command. So I'm actually creating a socket, and where I am giving the value 192.168.0.220. I think that's the one. Let's quickly see. Yeah, 220. 220. This is the IP address which I'm trying to connect. And using Python programming, not using NC, because NC was like not allowing me to write a lot of big data, and that software that I was executing was not something like susceptible to attack with that limited value. So I'll try to give it more value. So using Python programming, I will try to kind of, let's say, try to kind of access this one. And let's say I do this, and I got an error. The reason is that this is an integer. So let's do that. So now I think I should have been connected. So you see, server got a connection, right? As soon as I executed this code, sock.connect with this IP address. So using Python programming language, I'm able to make a connection. And now as an attacker, I will try to see if it is vulnerable to any buffer overflow attack. So what I will do is I will create a buffer. I'll create a buffer. Let's say I'll create a buffer variable, and I give it, let's say, I just give it A, and I multiply this value with, let's say, 5,000. Okay, so now my buffer is really big. It's much bigger than what NC was allowing me. It's a 5,000 characters of data that I'm about to send to server. And this is, guys, always read that here. This is what the attacker will actually do. This is how the attacker does. So assume that I am the attacker and I'm trying to exploit a vulnerability in a server, web server of your company, and trying to get a remote, trying to see like if it is vulnerable to any kind of attack. Okay, so I'll create a very big buffer, and now the next thing what I will do is I will actually send this buffer. Okay, so I'll send this buffer to the computer. So send this buffer. So as soon as I do that, I hope it will crash. Okay. So yeah, so there's one more thing, guys. Just let me just do that for you. So this is the server. Let me quickly do the Python 2. The reason why I picked Python 2 because this SOC send buffer actually requires object in bytes, but Python 2 allows sending the object in string character. So I'll quickly paste this out, and then I will quickly do this. This is done, and then I will quickly execute this. And as soon as I execute this, you will get a connection over here. You see, the server got a connection. And now I will do a buffer. Buffer is done. And now I am all about to send that big buffer to the victim. To the victim. Okay. So as soon as I press enter, I hope it will crash. And if you see, it crashed. Right? It got the A value, the A that I have sent, that you are seeing right now on the screen, the XP, and it crashed. And now the thing is that, guys, you might have recalled, you might have come across this screen multiple times, if I'm not wrong, right? Where the server is kind of crashing. And the thing is that most of the time, maybe most of you might have just clicked don't send or send error report. Thing is that this data, that if I don't send or if I just send it to the Microsoft for, let's say, the latest operating system, it's actually a gold mine. Okay, actually with this data, if the attacker has the knowledge, with the data that is about to be sent out to the Microsoft over here, the attacker can make tons of money just by the information that is about to go to the Microsoft over here. And why I mean to say that is that if I go, rather than clicking don't send or send error report to Microsoft, what I was going to do is I will click on this, click here. And if you see what it is telling me, it is telling me this server got crashed. The whole technical information is there, how the server got crashed. Okay, because this is what the attacker will be actually looking after, what the crash report was. Okay, and this is from where the attacker will be able to understand what the vulnerability is there. So now if you see something like offset 41, 41, 41, 41. Okay, can you just kind of guess what this 41 is all about? Any guess? Okay, so can you tell me the ASCII value of A? What's ASCII value of A? Can you remember like the big capital A was the ASCII value? I hope guys I'm audible, right?
Yes, sir, you're audible.
So it is 65, I think.
Yeah, I think that 65 is for small a. For capital A, it's actually 41. Okay, so that's the correct answer for the letter A that I have provided the server. The ASCII value is 41, and if you see that value is showing up over here, offset 41, 41, 41, 41. Okay, and what's this? Let me see if I have kind of made out the figure over here. No, okay. So what I mean to say is, so this is the one that we were seeing earlier, right? So let me just do this one. Okay, so this is the one. And what is happening right now over here is that when I have kind of sent out the big value of a very massive A law of character, what is happening is that that A is actually overwriting this value, the return address value. Okay, so whatever return address value was there, uh, in a default sense, okay, when I provided the when I provided the data, what happened is that actually overwrote the return address with 41, 41, 41, 41, which is the A, okay, in ASCII value, okay, and because that big chunk of data actually overwrote this return address, so when the function of the computer of that server was trying to exit from that function, once it has got the data, it actually read the return address, and that time what happened is that rather than the original return address, it actually got this junk data, which is 41, 41, 41, 41. And this 41, 41 address, there's nothing over there in the operating system and pointing to this software. And that's the reason why the software got crashed. Okay, and that's what you are seeing over here, offset 41, 41. This is the EIP value of the currently the EIP value is kind of like overwritten with 41, 41, 41, 41. Okay, and that's what happened when I executed the buffer overflow attack. So any question, guys, till this point? I will be explaining you. I will be showcasing that in Immunity Debugger. Okay, in a much better way, how the stack really looks like. But any question till this point? What I have done is that using buffer overflow vulnerability, I was able to kind of override the return address which was existing there with a garbage value of A, and that memory address doesn't make any sense to the operating system, and that's the reason why the software was crashed. And this is the same information that is about to go to the Microsoft. And if this is something which attacker can get, this is a gold mine for the attacker. So how the attacker will actually, let's say, prepare exploit, or let's say prepare a find out the vulnerability. So let's say for an example, your company is using, let's say for example, VLC software, for an example, to play the video files. Okay. So as an attacker, what I will do is that I will also download that VLC software at my end and on my end. Okay. And on my end, what I will do is I will try to kind of, in a similar way how I was trying to kind of exploit the vulnerability, I will try to kind of see like if that VLC software is, let's say, the latest version of VLC software, is it susceptible to any kind of attack like buffer overflow attack. Okay, and if the VLC software get crashed due to different kind of means,